So in this video, we're going to talk about limits. All right, so limits. Okay, so a limit is the value that a continuous function will approach as values of x are approaching some value. So let's go ahead and draw this out. I got a graph here. Got x and y axis. Let's put a little value c somewhere in here along this function. This function has a discontinuity right here, and then we'll put a over here. So for this function, which we'll call f of x, we have a limit. So the limit, as our value of x is approaching c from the left side of the function, is going to equal a. So as we're approaching c from the left side of the function, we start to approach the value of a for f of x. Now, what is the value of f of x at this point? Well, the value of f of x at this point is a. However, we can also do this. We can say, what is the limit of the function as x is approaching c from the positive direction? And we'll call this value right here, we'll call this b. So as we're coming in from this direction, the limit of that function is going to equal b, because that's what that function is approaching as we come from the right. So that is going to equal b. Now, we only have one function value at that point, but we can have multiple different limits because the function is discontinuous. It has a discontinuity in the function. Now, suppose we have a continuous function. Well, for discontinuous functions, we can take limits coming from either side, but we cannot have a defined limit at that point. So if we say the limit as x is approaching c of f of x, we can just say that that's undefined, or it does not exist. All right, but that's because it is a discontinuous function. For discontinuous functions, where we have jump discontinuity or something of that nature, we cannot have a limit defined for that spot on the function. Now, we might be able to find a limit over here or over here, but not at that discontinuity. So with that being said, let's go with a continuous function with some value c at this point. We got x and y axis, and then over here we'll have a. So the limit, and we'll call this g of x. The limit as x is approaching c of g of x is going to be a. Also, g of c is equal to a. So the value of the function at c is equal to a. Now, the reason this is important is, as we'll talk about in the next video, is we want to be able to find slopes of tangent lines on this graph. So we might want to find a tangent line here or a tangent line here, and this is what we're looking for. So we're trying to come up with a way that we can find values of a function as we approach that spot on the graph. Not necessarily specifically at that point, because that might be inconsistent. Say we might have a hole on the graph here, but it's defined down here. Say we have a piecewise function or something. We can still find the limit of that graph as it's approaching this position by using these tools, we just won't be able to, and that'll still let us find the slope of the line at that point. All right, so we'll talk about using the limit definition of a derivative, or the limit definition of finding the slope at any given point on a function in the next video.